Objectives and approach. In disaster-stricken or remote areas, getting aid to those in need can be incredibly difficult. Uh, Difficulties like harsh terrain, bad weather, and a lack of infrastructure make traditional methods slow and resource-intensive. Our project aims to tackle this challenge by using autonomous drone to deliver medical aid faster, farther, and more effectively. Our system is designed to minimize human intervention while maximizing impact. This includes a drone with the combined purpose of reconnaissance and delivery, which surveys areas, identify people in need. It sends the information back to our home-based system and deliver the medical supplies directly to those locations by bypassing the need for ground teams. Moreover, at the center of the operation is our AI-powered home-based system, which coordinates drone missions, processes incoming data, and makes smart decisions where aid is needed most, all with little to no human interaction. Uh, I'm responsible for the AI model, and I pre-trained the YOLO V8 large model uh, on the VizDrone dataset as part of our training pipeline. And we also did various image augmentations such as shifting, scaling, rotating, adjusting to simulate rugged drone flight. And right now our system currently runs on a PC instead of the Jetson Nano. And then with that, we were able to utilize the larger model before it was the medium, and that we improved accuracy and detection capabilities. And based on Dr. Yang's suggestion, I also implemented Ghost modules into the convolution neural network architecture, allowing it to generate more features with fewer parameters, as well as from before, also training convolution neural network on further data sets as UAV-DT, Akutomo Action, D-Destra, and CrowdHuman.
Hi, my name is Ian Blankenship, and today I will be talking about dataset augmentation and some edge cases and metrics where it relates to our AI in our project. On the left here, we can see an original image with boundary boxes. We can see there's no edits, it's as the picture comes. Moving to the right, we can see an augmented image updated with new boundary boxes. So we see the image is rotated, darker in contrast, and it is more blurry, in addition to updated boundary boxes where it relates to their shape and their quantity. We can see they stand out a little bit more and that there are fewer of them in the right image. Where it relates to edge cases and model metrics, we can see that we successfully, in every image shown, identify the people or persons located in said image. For the data set, we did have to edit the labeling for people, so there were some that were labeled as people or persons or other things like this, and we opted to label them as a singular person label, um, even where it relates to a group of people.
So as the iterations have progressed, the tail has just increased in size. And as we keep working on constructing the drone, we see the issues that come up and the issues that we'll need to resolve over the next iteration. So where we're at right now, we need to increase the size of the rudder so we can actually control the drone on the ground. Slide.
This is the current 3D model of the drone. It shows all the framework on it. It also shows where the payload is placed and the camera mount. This is a rough view of it. Here is the completed drone covered in the ultra coat with all these small adjustments made so the drone works. It'll be talked about more in the demo video.
All right, so for the final challenges remaining, Sebastian covered it a bit, but we have the tail of the drone that needs to be adjusted to increase in size. Other things we need to do are add modifications to the mission planning software, add the dropping mechanism into the drone and then test it, adjust any of the electronic components, to shift weight or fix the wiring, and then ensure that the feeds are going through into the home base and displaying everything we need to display. And then planning for repairs because, flying a drone, testing it, it might break, crash. So planning to make any repairs necessary or change any other shapes of the parts to like fit sizing.
This payload, it goes on the bottom of the drone. The landing gear is this tall to be able to actually handle this. We're in the process of attaching the parachute to it so it doesn't just come down hard. And the dropping mechanism needs to be attached. Right there is the camera mount. Right now it's just mounted. This is because this controller is only a 6-channel and we just don't have enough ways to control. This is the one that controls the modes. The first one is of course manual, then it is autopilot, and then fly-by-wire. This is our completed drone. There's still some sections that are still being worked on, but with a few changes, this should soon be able to fly relatively well. So right now it is just manually controlled. Right here are the ailerons, which can be actuated. That's the left aileron, and then the right aileron. The flaps still have to be connected. Then back here, the rudder, and then the elevator. Now, of course, we have the motor. And of course, this is on low for safety reasons.